What was the Azoic? It is known as Azoic Eon, Hadic Eon, Hadean Eon, Azoic Era incorrect, or simply as Azoic at the earliest and longest division of the geological timescale. It is the first of the Supereon known as Precambrian, that is, prior to the great explosion and diversification of life that occurred at the beginning of the Paleozoic. The Azoic begins in the most remote possible times. Those of the formation of our planet itself, about 4,657 million years ago. It culminates at some point close to 4,000 million years, approximately, with the transit towards the Archaic Eon. Their names come from ancient Greek and means on one hand, without life, or animals too, and zoe, azoico. Since this period is before the appearance of life on the planet, and by the other, infernal, or underworld. Since Hades is the name that the ancient Greeks gave to the land of the dead. The study of this time is extremely difficult, since there are no fossil remains to find and most of the stones from this time have changed over millions of years of transformations. One of the few known minerals dating from this time, Hadic rocks, are zircon crystals. Origin of the solar system. Azoic, Sun. During the Azoic, the eternal burning content of the Sun would have been formed. We do not know too much about the formation of our solar system, with its planets and the Sun in the center. However, it is known that the elements that gave rise to it were gas and stardust. Indications of the relative abundance of heavy elements suggest that they stem from other previous space cycles, such as a supernova, the explosion of an old, massive star. In its interior, nuclear fission was already generating elements heavier than hydrogen and helium, abundant in the heart of our tutelary star, the Sun. In this way, by action of their own gravity and internal atomic reactions, both the content in eternal combustion that makes up the Sun and the planetesimals, flattened disks of gas and dust, would have been formed. From them arose the 8 known planets, their satellites and the asteroids that make up the belt in the middle of the solar system. Origin of the Earth. It is not known exactly how our planet and its neighboring planets were formed. However, observing similar phenomena from a distance, a theory was reached. The remaining matter of the formation of the Sun, united and stabilized, initially agglomerated in a planetesimal disk, more than 4,500 million years ago. This is the nebula hypothesis, which proposes that our planet was formed from a cloud of dust and gases, whose gravity caused them to converge and intermingle. It condensed and cooled enough to have a firm and defined shape, rounded due to its movements. Thus it began to exist as what we normally call a planet. Origin of the Moon. Azoic, Moon. The Moon is thought to have been part of the protoplanet that some call T or Orpheus. The most widely accepted theory about the formation of our natural satellite is the so-called Great Impact hypothesis. According to her, the Moon was part of a protoplanet that shared Earth's orbit and that some call T, Thea or even Orpheus. This protoplanet would have collided with the early Earth around 4.533 million years ago. As they did so, the cores of the two fused together, but left a scattered ring of debris from their bodies, floating around. These would have given rise to 2 natural satellites, one of which ended up crashing back into Earth, at that time little more than a melt of rock molten or vaporized at 4,000 degrees Celsius. The other satellite remained at the necessary distance to orbit around it, and today it is known as the Moon. Azoic division. Given the few geological records that have survived from such early times, there is no proposed subdivision for the Hadic or Azoic Eon. Everything that happened more than 4 million years ago is simply considered part of it. Geological characteristics of the Azoic. Azoic, magma. The early Azoic stages were charged with intense volcanic activity. The geological history of the Earth begins in the Azo, with the formation of the Earth's crust and the cooling of the planet's core. Its first stages, of intense volcanic activity and frequent bombardments from outer space and the solar system, allowed the contribution of minerals and sediments that ended up originating the first cratons. Proto-continental nuclei that moved in the Earth's mantle in a similar way to the continents of today. In the next eon these cratons came together and moved apart, changing their shapes and growing until they became shields, the cores of today's continents. It is difficult to determine exactly what kind of geological changes occurred in the Azoic. Azoic climate. Archaic. In the Azoic, a mass of vapors boiled over the mantle of liquid rock. The primitive atmosphere that formed next to the planet was a mass of gases very different from what it is today. Initially it was a mass of organic vapors similar to ammonia, methane and neon, seething over the mantle of liquid earth rock at thousands of degrees of temperature. For the necessary cooling and stabilization of the atmosphere to take place, it took a long time, but also the contribution of fundamental compounds that are presumed to come from volcanism and the bombardments of meteorites of that time, carbon dioxide, hydrogen, together with water vapor. With these two gases in the atmosphere, a stabilization and a decrease in temperatures began to take place, which allowed the appearance of liquid water despite temperatures of around 230 degrees Celsius, and the consequent cooling of the entire planet. The presence of liquid water on the planet dates from practically its birth, around 4.4 billion years, according to the study of Hadic zircons. In any case, the climate of this entire period was infernally hot and incompatible with life as we understand it. Living things in the Azoic. In principle, life did not exist during the stages of primary formation of our planet. The first recorded bacteria date from the following eon, 3.5 billion years ago. However, there are theories that since the presence of liquid water and sources of energy on Earth, it is likely that were already occurring processes organic chemicals which lead to the occurrence of the first primitive life forms. Whether molecules auto-replicantase RNA, coachivates or whatever. The oldest rocks in the world. Zircon, Azoic. Zircon crystals date back 4.4 billion years. The oldest minerals on the planet have been found in the sedimentary region of Western Canada and the Jack Hills region of Western Australia. In both cases they are individual crystals of zircon or zircon, a mineral composed of zirconium silicates ZrSiO4, with a variable color but more or less transparent and yellowish. It is one of the most abundant on Earth, dating 4.4 billion years ago, practically as old as the planet itself. Importance of the Azoic. The Azoic is a dark period in the history of the planet, but fundamental. The basic chemical reactions for the establishment of the planet and to start life took place within its more than 500 million years of duration. Also at this time the primary geological formation of the planet occurred. Questions about how it all started lie, redeemable or not, in this remote eon. Next eon, the Archaic. During the Archaic Eon, the intermediate eon of the Precambrian Supereon, life arose on our planet, although in primitive conditions very different from what would come in the following millennia. Sometimes the Hadic or Azoic Eon is included as a remote and primal part of the Archaic, since it is not known for sure when one ends and the other begins.